How are we going to solve these problems in today's episode? Well, today we have our next section of Algebra 1, Unit 1, solving multi-step equations. So, here are the problems, and they may look a little tricky. So, the question is, will we be able to figure out these problems in the future? Will we show how we are going to solve them and use them in the real world? You'll find out today in this episode of FEM, Foundations of Excellence in Mathematics. And this is FEMCore. Whenever you're struggling in the hands of math, let them know you will release your wrath. Prove them wrong and show that you are strong. That is how you will move along. They gave you numbers, hoping you fall, but you rose up, solving them all. From numbers to proof, you shattered the wall. Now fam stands proud, answering the call. Fam is here, face your fears. No more tears, just shifting gears. Push the limit, break the mold. Truth and logic, brave and bold. Fam is here, strike through doubt. Raise your voice and let it shout. Let them hear your rebel cheer. Fam is here! Fam is here. They're trying to box you in a grade. Told you that you never make the grade, but you burned the rules unafraid. With every graph and line you made, they said stay silent, follow rules, but you rerun the game, broke all their tools. Fem is a forge, you are the flame. This isn't math, this is your name. This isn't just math, this isn't just math, this isn't just math, this isn't just math. This is your name. Letters and numbers dance in the light. Each solution is spark in the night. You're not alone, you're part of a team. Fem is the fire that fuels your dream. Fem is here, rise and shine. Let your brilliance realign. Turn confusion into might. Darkest problems into light. Fem is here, sound the bell. Crack their system, break the shell. You're the future, bright and clear. Fem is here. Now they know. Now they see. This was never just about math. This was about freedom. This was about you from the dawn of FEMCore. That is going to be Fem's intro for all the episodes onward. That was FEMCore, which was written and directed by me. But anyways, let's get to today's episode, where we have 4 problems we're tackling today. We have 100 equals 4 times 1 minus 3a, 97 equals 2k plus 7, parentheses, negative 2k plus 7, negative 102 equals negative 3, parentheses, 4v plus 2, and negative 13 equals 7, parentheses, n minus 2, and minus n plus 5. Let's solve for each of these. So, first things first, I'm going to take a screenshot, because it's going to be pretty useful if we're going to screenshot these. So, now, we have to align with FEM's mission. We want to make every single problem be used in the real world. So, let's go ahead and take a look at its scenario. So, let me get my pen real quick. So, let's just say that this right here, this person is you. So, this is you. You are tightening bolts on a suspension bridge, and the tension in each cable is modeled by, well, this equation, basically. And A is the angle adjustment in degrees. So, if you get A wrong, the bridge will be slightly off balance, and over time, the entire structure could fail, which would cost millions and lives, which means this person can die.
Oh, no!
So we don't want that. So your ability to solve for A is the difference between a safe bridge and a catastrophe.
Oh, yes.
So let's go ahead and solve this problem right now. Because if we don't, the bridge could collapse. Now, to solve problems like these, first things first, we have to understand the parentheses means multiplication. And let's review how that works. We take 100. Actually, you know what? No, scrap that. We're going to do a faster way. Check this out. Backwards, so we know that 4 times 1 minus 3a will be more than that, right?
Oh,
So,
yes.
if we divide by 4 here, that's reversing the multiplication, meaning that these 4's will both cancel out.
Wow.
Let me prove to you how that is true. 1 times 4 is 4, and 4 divided by 4 is 1. So we got to the same problem. Let's try another one. How about 3 times 4 equals 12 divided by 4 equals 3. So if you multiply by 4 and then divide by 4, you'll get the same number anytime. And this is a proven statement. We just proved it.
Yay!
So by logic, this works, and we just proved that it cuts out. So if we do the same thing with 100, 100 divided by 4 is equal to 25. So it would be 25 is equal to 1 minus 3/8. And we can put it in parentheses, but it's not very necessary because it just cancels out. Yeah! So we just do 1 minus 3a, no parentheses. Now we want to subtract by 1 on both sides. Let me show you why this is true. Because if we add 1, as a common mistake many people make because there's a positive 1, we would get this situation. And if we divide by 3, negative 3 actually, and get our answer, let me just do that on the calculator real quick. And if you want to get a calculator, go ahead and do that, but you don't really have to because I'll calculate it. We take minus 3, and we'll figure out that a is equal to negative 8.6 repeating. Now, here's the thing about math. We want to make sure we have a 100% correct answer. So if we plug that back in, we would take 100, and we would have to check our work here. So 26 divided by negative 3, and we would multiply that by negative 3 to get 26. 1 minus 26 is negative 25, and multiply that by 4 is negative 100. So that's why this will not work, because we are going the exact opposite way of where we want to go. So it's not 8.6, because once we solve it, we have to check our work.
Yes!
And that's one of the key features, and that's what makes math simple. Woo! So back to the problem. We take 24 is equals to negative 3a because we subtract 1 on both sides. 25 minus 1 is 24. So after we do that, we have to divide, because remember, like we proved it earlier, this cancels out with the trick where you always lead to the same number after multiplying and dividing. So with that in mind, these cancel out. We're just left with a. 24 divided by negative 3 is negative 8, because any positive divided by a negative is a negative. Let me show you why that's true. So when you take a positive number and you divide it by 3, that's keeping it in the same dimension. But if you do it like a negative is like flipping it. So you would flip that same number as well. So let me just pretend we have a number line here. This is the negative sign, this is the positive sign. So since we have a 24 and a 3, we're essentially just combining it and putting it to a close number, because we're cutting it by 3. So that means what we would do is we would subtract. And if you saw in my last video, go ahead and check that out, we would subtract many times. So 24 minus 3 minus 3 minus 3, and we would eventually get to 0. Because after you get to 0, you count the amount of times you subtracted by 3, and that's your answer. And that's 8. However, we are doing a negative number, which means that if we're subtracting a negative number, then we would go up to infinity. So if it was a positive number, that would be a bad sign. So what do?
I don't know.
We do the exact opposite. So 24 minus 3, instead of 1, it would be negative 1.
Okay.
Because essentially we're subtracting a negative 3. And it's going to a different dimension. And vice versa. So it's negative 8. And then that's a. Now we have to prove that this is true. So 1 minus 3 times negative 8, because whenever you're having a variable and a number, That's the same thing as 3 times a. It can be 3a, and many things. So you do -3 and -8, and that would get you positive, because 2 negatives make a positive. Let me show you why that is true. So again, we just discussed that multiplication is the definition of repetitive addition. So 8 times 3 would be equal to 8 plus 8 plus 8. And that would be added 3 times.
Yes.
Now if we did negatives, then that would be 8 times -3. Which would then equal, well, actually, it would just flip the sign of the 8. So it would be -8 times minus -8 minus -8. So in this case, since we have 2 negatives, we would have -8 flipping the... We would have 2 negatives, so we would have -8 times -8. But since it's negative, it turns back to positive, therefore flipping the dimension. So that's why that's true. So then we have 1 plus 24 is equal to 25 times 4 is 100. And since that's equal to 100, that's our answer.
Woo!
A is equal to -8. I'll put this up for a few more seconds. So we did. If we had got that wrong, we would have destructed the bridge, and it would have costed millions. But good thing we had the skills to know that. And that's why that's essential in film. Give yourself a yellow star. Whoop, no, that's black. My bad. Give yourself a yellow star. I keep doing this, my bad. Give yourself a yellow star. There we go. Alright, let's move on to our next problem. Let's see here. It says 97 equals 2k plus 7, parentheses 2k plus 7. So, let's see here. So, let's just say this is U again. Let me erase this yellow thing. That's kind of embarrassing. This is U. I'm not going to draw your face. You're managing the budget for a school fundraiser. So, let's just say this is like you. You're like, hey, I'm raising money. You know, I want that money. I want that cash. You're raising money for school fundraiser, and the total amount raised right now is $97.
Woo!
$97 right here, yep. Which comes from 2 sources. Direct donations from 2K, and, direct donations 2K, and the event ticket sales 7 times -2K plus 7. So, if you miscalculate K, you'll either overspend, and if you overspend, you'll be a little sad. Well, you'll be very sad. And you'll either overspend or you'll come up short. So, you'll either not have enough money or you'll potentially be in debt. Because you'll never know if you're poor or not.
No.
So, that's why this problem exists. We're making a fundraiser. So, we better know how to solve this. So first things first, what I'm going to do is, since we do have another variable, I cannot divide by 7. And even if I did, 97 and 7 don't comply. So we're going to do the old-fashioned method. We're going to multiply by both of these. Now, a common mistake people make is that they do 7, and they multiply it by, well, actually, that would only be the case for, like, terms. They would do something like... So we would do 7 times -2k and 7 times 7. Now let me show you why that works. Because we would do -2k plus 7, and then we would add that 7 times. That's what multiplication means. Which means that, essentially, we can... 7 times -2k plus 7, to make it a little simpler, we can rewrite that as this. Looks a little easier to read, huh? Well, if you combine it, addition doesn't really have that effect. So, we would do -14k plus 49. And we would add that to our already 2k. And this would all be equal to 97. So, now we have a choice. A, we can solve the like terms first, and like terms are just variables that have the same variable. Or B, we can solve, let me put it back up here. We can subtract on each side. So, let's see here. Let's go ahead and subtract 49 on both sides, because I think that'll be better. So, and we just proved it from the last problem. So, 97 minus 49. We would take a 1 from here, 8. 17 minus 9 is equal to 8. Then 8 minus 4 is 48.
Woo!
Or you could have just used a calculator. But it's fine, because calculators are encouraged in math. You're using your resources. So now, that means this turns into 48, and we cancel out that previous number. Now we have 2k minus 14k. So, just ignore the k's, because we can technically just do 2 minus 14, because it's the same variable either way. So if we do 2 minus 14, it would be negative 12. Now let me show you how I just did that. If we take 14 minus 2, flip up the variables, we would get our answer, but then you just add a negative sign.
Wow!
That's a pretty cool trick to know. So let's try it on another problem, shall we? So let's do 58 minus 100. Now this may look a little grueling, but if we do 100 minus 58, it looks a little simpler, right? We would just put 42 because 10 minus 8 is 2. Carry that, and then we would just put negative 42.
Great!
Simple. We don't have to worry. We can just do that variation. Now that's optional, but it's a cool trick. Very cool. Definitely should try that out someday. But anyways, we have negative 40. We have negative 12k. So now we would do 48 divided by negative 12. And if it's a little tricky, you can do 48 divided by the positive 12. And then you can get our answer. 48 divided by 12 is 4.
Woo!
And then we just do negative. So negative 4. Which means that k is equal to negative 4. Now hold your horses. We have to check it first. Because if we miscalculate, remember, we don't want to overspend or come up short. So let's go ahead and plug it in. And instead of actually just doing this, let's just get our answer 97 and then plug in the number right here. Plus 7 minus negative 2 minus negative 4 plus 7. So let's put all this into the calculator. And if we have a match, then we're good. 2 times negative 4 plus 7 times negative 2, negative 4 plus 7 is 97. So that means that since this is 97, this is a pass.
Yay!
Which means that k is equal to negative 4. Or, in case of our fundraising scenario, k is the number that we have. So means we just had the fundraiser stay on track. If we messed it up, we could have lost crucial funds and future support. So we just did 2 problems right now, and they were pretty long. So I'll give you guys a little break today. I'm going to only do this last problem.
Okay.
But if you want to do the last one, you can go ahead. I'll give you a scenario at the end. But anyway, let's do the last problem together. So let's see here. Let's use this for scratch paper. So we have 102 equals negative 3, 4v plus 2. So you're programming a robot arm that moves boxes. So let's just say this is you, and you're programming let's just say a robot arm. I'm pretty bad at drawing, so just ignore it. A robot arm that moves boxes in a warehouse. So you're looking pretty confident on this robot arm. And then the force applied is modeled by this problem right here. That's the force. So, a little bit of physics there.
Wow.
But I know some of you may not be taking physics, but still. Where v is the speed setting. If you calculate v wrong, the arm might apply too much or too few. So, yeah. Getting v right means the warehouse is safe, and smooth. So, let's solve this problem. So, okay, we don't have any more variables. So, first of all, let me check if 3 goes into 102. So, let's just check that real quick. It does. 102 divided by 3 is 34. And since we have 2 negatives, we can do division. So, go ahead and get this out of the way real quick. So, that's really good news. So, let's do negative 102 divided by negative 3, and it's 34. And
nice.
From proving the problem right in the first problem, 34 is equal to 4v plus 2. And now, this looks pretty simple. I think we got this. I'm going to let you do the rest of it, based on the skills we learned. So good luck. Okay, so now that you paused the video, hope you did, we have 32, because we subtract 2 on both sides. We just proved that from problem 2, equals 4v. Divide by 4 to cancel out. Prove that in the first problem. V is equal to 8.
Woo!
we plug and chug. So let's do 4 times 8 is equal to 32. Plus 2 is 34. And would you look at that? I don't even have to do anything else. You wanna know why? Because if we divide negative 3, 100 divided by negative 3 is 34. 34? 34? You see a match? So that means V is the speed setting. So the speed setting must be 8. So it's 8. Good job. You did it. A round of applause to everyone. With those skills, you just learned how to do multi-step problems with 3 problems. But that's not all. You just solved 3 problems and saved the planet with every new problem that we do in FEM. Great job. Now, if you want to do this last problem for homework, because I'm feeling very nice, I want to only give you 1 problem to demonstrate your knowledge. Here is your scenario. So, if you don't want to do the homework, then you are free to go.
Goodbye.
But if you want to stay, you are signing up shares for an important conference. The seating plan uses the formula, this formula. And, N is the number of rows adjusted for aisle space. If you get N wrong, the room will violate fire safety codes, forcing the event to be canceled, wasting time, money, and disappointing attendees. If you solve N correctly, the event goes on smoothly and safely. And that's it. I hope you enjoyed today's episode of FEM. And remember, let's say our pledge, which we will say at the end of each episode. I pledge allegiance to the Foundation of Excellence in Mathematics, one organization under Landon, with purpose, compassion, and accessibility for all. I'll see you all next time. Bye!